Good morning, all. And today we are discussing System Software and Operating System Lab. So, what is system software and what is operating system? So, every concept you have learnt it in theory, but now in theoretical concept, how we can explain in terms of practical programs and which languages that we can use if you want to implement the system software and operating system lab, right? So this lab is mainly is used for verifying what exactly the different phases of the compiler as a system software we can work it with the different phases, and again it is interlinked with your operating system concept, like how the files can be managed, how the memories can be managed, and how the page replacement algorithm, what is a deadlock. Like by combination of both system software and operating system, this lab covers all the different types of logics, and again it covers the phases of the compiler and operating system main concepts implementation, right? And now we look on with what are the main objectives we can identify in this lab programs, right? So it is mainly used to make the students to familiar with the lexical analysis and syntax analysis phase of the compiler, and as we discussed in theory concept, so different phases will be there, and in the first two phases plays an important tool, that is a lexical phase is a lex scanner, and next syntax phase is a parser or a yak, and again you can use C++ or Java program to implement these two phases of your compilers. And the next objective is it enables the students to learn different types of CPU scheduling algorithm. As I told, it is an operating system concept. You will be identifying different types of scheduling algorithms, how the scheduling algorithms will going to be works, different parameters that is required to process the given logic of the program. So everything you're going to be learning, and again it is one of the objective of your lab. Nextly, it is going to be make students to able to implement memory management. Again, you can implement some memory management algorithms like page replacement, deadlock handling algorithms, and the page replacement FIFO, least recently used, optimal, and based on the different algorithms, you will be covering all the different types of operating system applications. So this gives some basic objectives that is going to be provided by this lab. And again, if you come with this implementation part as tools that is required, so basically when you're implementing any program, so we'll be having some structure, some syntax will be there, right? And same thing if you go for system software and operating systems lab, so basically this algorithms is also covers within basic syntaxes, right? And that syntax always starts with your header files and implementation, what exactly that logic will be there, and again what type of input you're taking, output you're taking. But majority of system software and operating system program, we are not using with a printf and scanner, we'll be using directly that input file, that file input we are taking, and again we'll be taking from different sources of input. Like that we'll be using some examples programs, and you're implementing your system software and operating system programs, right? And next you come for outcomes. What are the different outcomes that are available? So the first outcomes we can identify is we'll go identifying what exactly that working of lex and yak compiler for debugging a program. So if you take any program, so debugging plays an important role, so compilation is plays an important role. Out of that, how that lex and yak is going to be plays an important, this is an outcome. After completing the lab, all the students will come to know what exactly that lex and yak, that's the first outcome of your lab. And nextly you will be defining the role of lexical analyzer, and what exactly that regular expression, what is a transition diagram. So as you have studied in the automata theory concept, so what is a regular expression, deterministic finite automata, how we can represent transition diagram, how the states are going to be modified when you're representing a string, how the transition is going to be carried from one state to another state, and generally you'll be representing in terms of regular expressions, grammar, and different logics you'll be writing. So again this will be access one of the outcome of your given lab. And nextly you'll be understanding what exactly that context free grammar, so VTPS, that is a terminal, non-terminal production as well as symbol, and parse tree construction. So parse tree construction, again it's a second phase of your compiler. So we'll be generating the syntax tree, or we can call it as a parse tree. So then we are taking with the top-down parser, bottom-up parser, then leftmost derivation, rightmost derivation, like that. Different processors are there, right? And finally, when you're implementing any program, it's not mandatory that you have to use for specific tools. So it is a generic tools, and we can use any number of tools. And by using this, another outcome is you can verify with the new tools and technology that is used for compiling your programs, right? And nextly, user can develop a program for solving the parser problems, like SLR parser, LALR parser, predictive parser, non-predictive parsers. Different parsing techniques are there. That is a theory concept. Again, in the problematic and the programs we are discussing in programs of your system software and operating system programs, right? And next we'll be learning how to write a programs and how to execute a program very faster, means by minimizing the logic, how we can execute the program very faster. That is also one of an outcome of your system software and operating system lab, right? So now we look on what are the different questions that are available in this lab. right? So firstly, lab programs, it starts with a lexical program. So in the first program, we are having how to evaluate arithmetic expression by using some integer data and operators provided with an operand. And again, the main outcome and output of this program is user has to count identifiers and operator that are present in an input. So what input your user is giving, in that you have to identify what all identifiers are available and what all operators, and user has to count it. So that count is very important, and user has to print it, right? So counting identifier and operators present, and afterwards user has to display, and afterwards user has to count it. The three process has to be there in the first A. And in the first question, in the B sub question, we are writing within YAC program, right? And what is the objective of this program? So the write a YAC program to evaluate arithmetic expression involving operators plus, minus, star, and division. So as I told, when you're discussing the theory concept, when you're implementing any YAC program, YAC is going to be takes an input from the lexical program, that is a tokens, right? So even though if it is just an YAC program, user has to first create a lexical program. That output of lexical program tokens will be accessed and input to YAC program. So what is the main outcome and objective of this program is user has to evaluate an arithmetic expression, that is a valid arithmetic expression. So keep it in mind, user has to write a program either to evaluation only valid arithmetic expression, or user has to write a evaluation of any expression, that depends. So the compiler is designed like that. So what is the reason 5 plus 6 is gives 11 is nothing but they already define a compiler, plus should be had two numbers. Why 5 minus 3 is equal to 2? Because it's already defined operator minus is used for subtraction, like that. Previously they are already defined, some rule sections is going to be defined, right? And again the program is going to be depends on both lex and YAC. And nextly, second program is design, develop, and implement your YAC program, that is going to be end up with the strings preceded with a B by n number of A's, that is with the help of a grammar a to the power of n as well as p, right? So again it is comes under automata theory concept, but there we will be taking a grammar a to the power of n and b, means n value will be there. For example, if I take n is equal to 2, a will be 2 and followed by b, means all the strings are terminated with a b. All the strings are terminated with a B, and only exactly one B should be there is a terminal. So very importantly, you have to write a DFA. So start symbol n is equal to or not equal to 0, that is nothing but epsilon will not going to be taking. Minimum B is an output for a given grammar. So if you represent a deterministic finite automata, so B is an input. If n equal to 0, a to the power of 0 means 1, only B is a state. Or if n equal to 1, the output string and output representation of a DFA is A followed by B. If n equal to 2, 2 A's followed by B. You can put a loop in a value of n, then n number of will be taken based on an A is going to be represented. That is your second question. And number 3, you will be implement YAC and C program to construct predictive and LL1 parsing. As I told, it's a theory concept. The grammar will be given. User has to create a construct predictive parser or LL1 parser. So based on the grammar, user has to print a table format. So for the given grammar, user has to identify how to derive a string, and the string is given as ABBA followed by dollar, and dollar represents terminal of a symbol or end of a terminal, or it specifies end of a string. So for a grammar ABBA, user has to derive a string with the help of an predictive LLL parsing table. The grammar is already given, A tends to AAB and B tends to BB followed by epsilon. It is not a E, it is an epsilon, right? Nextly, fourth question, design, develop, and implement YAC or C program to demonstrate shift reduce parsing. So fourth question is entirely different from the question number 3. Question number 3 is also parsing concept, but it is an predictive or LL1 parsing, but it is an shift reduce parsing. And again the grammar is different, and identifying the string is also different. Here we are identifying string is ID plus ID star ID, but there you are identifying the sentence as a string ABBA, right? So two different parsing techniques and two different rules, grammars, and two different resultant string, right? That is your fourth program. And next, fifth question is design, develop, and implement a C or Java program. Just identify the question. Either user can write a C program or user can write a Java program to generate a machine code using a triples of the statement A equals to minus B star C plus D, and it is intermediate code representation in 3 address format, right? So as we know, when you are representing addressing format, assembler directives, so we are having that registers concept, right? So if I take A is equal to B, it is a simplified high level language syntax, but according to compiler, according to assembler, first it will move a value B value to a register, then it will move B value into another register, then from that register it will move a value into another variable called it as A. Means it will take 4 different steps. If you want to perform a single operations within a compiler, within a computer, it will take 4 different steps. Same thing, user has to use a machine code generation here. for an expression a equals to minus b star c plus d means, and expression is already given that intermediate code in 3 address format, but you need to take it in an address format. First we need to move b value, and again that should be added to t1. Next we need to compute c plus d by moving into register. Then finally we need to add t1 and t2. Then resultant is going to be stored in a value, that is nothing but store. Means we will be using load instruction as well as store instruction to compute the 3 address intermediate code representation for an expression a equals to minus b star c plus d. That is your 5th question, right? Again in the 6th question it starts with an lex and yak program concept, right? Very simple concept. You will be writing a lex program and user has to eliminate a command lines, and that should be copied to resultant separate file, right? Very simple logic. Means in the 6th program you'll be creating one C file, and that C file will contain some command lines. That command lines will be there, but the lex program has to identify that C program as an input, and if any command lines will be there, that lex is going to be eliminating that command line and it will copy the resultant file into another output file. Means you will be creating a 2 files. One is an input file, another is an output file, then lex file. Very important. Means for this program, 6th program, user is creating 3 different types of files. One is a main file called as a lex file. For that lex file, 2 files will be accessed, an input and output file, and in that input file user will be writing C program, and that C program will contain some command line, but after processing logic of the rule section, declaration section by the lex program, it will eliminate any command lines. If command line is available, it will eliminate, and then it is copied into new file, output file, that is already created by user. So that is the logic of your 6th A. And what is the 6th B question? Write a YAC program to recognize valid identifier, operators and keywords in a given text file, right? Again in this program minimum 2 files is required, minimum 2 is needed, but in 6th program 3 files is needed. One is a lex file, input file and output file. In 6th B question, user has to write a program, YAC program, and again as I told, YAC program means lex program will be there, lex program output will be taken as input to YAC program. But what is the logic of the program? What is the main objective of the program? User has to identify valid identifier, operators and keywords. For example, if I take simple C program, in the format of addition of 2 numbers, I'll be adding hash include stdio.h void main. Within that I am declaring 3 variables. In the 2 will be initialized and another C is an resultant variable. Then afterwards C is equal to A plus B, then printf the resultant value equal to C. In that simplified program, I need to identify how many identifiers. A, B, C is an identifier, and operators, plus is an operator, equals is an operator, then keywords, hash include stdio.h is keyword, then again void is a keyword, main is a keyword, again printf is a keyword. Like that you will be segregating, you will be separating all the sequences in a given program into identifier count, operators count and keywords in a given text file, right? That is the logic of your 6th B. And next we move on to 7th program. So 7th program is your operating system concept, right? On operating system concept, again user can implement with either C syntax, C++ syntax or Java program syntax, right? And again it is consisting of 2 questions. One is the shortest remaining time, another one is a round robin scheduling algorithm. As we know, in any operating system, scheduling algorithm will be there. It will schedule the process to be executed, it will allocate a memory for executing some process. So in that we will be using 2 algorithms, shortest remaining time and round robin. Like the different scheduling algorithms are there, but we are tracing within shortest remaining time and round robin scheduling algorithm, right? And according to that question, we can easily identify shortest remaining time. If I have 3 processes, and out of that, if you want to choose any process, means firstly process will be chosen a shortest remaining time. So which process is having a remaining shortest remaining time to complete the execution, so that will be chosen. But in round robin we are having a time quantum, some fixed amount of time will be there. So within that the process will complete, it will stop the execution. If not, it will shift it to next process. So based on the time quantum, total time taken for execution of a given process, round robin will work. But shortest remaining time, it will check for a process which is having a remaining time, minimum remaining time, shortest remaining time. Based on that, the process is going to be executed, and there you will be calculating turnaround time, waiting time, burst time will be given, n number of process will be given, how much time it is going to be computing, total average time will be computing, total turnaround time will be computing. Then you are going to be verifying different quantum sizes for round robin and different time sequences for shortest remaining time. Then we are going to be checking output in n number of sequences of data, right? That's your 7th question. Next, 8th question. So 8th question is your design, develop and implement C, C++ or Java program for bankers algorithm. right? So again, as we all know, Banker's algorithm is mainly useful for deadlock avoidance, right? To prevent a deadlock, we're using a Banker's algorithm. Means whenever you are thinking about Banker's algorithm, so first concept comes into your mind is a deadlock concept, right? First, what is deadlock? What deadlock is going to be created? How to avoid a deadlock? So by compiling all the features, by computing all the characteristics, then we will go for Banker's algorithm. So it is going to be avoided deadlock creations. So by taking some data structures as well as the parameters, available matrix, need matrix, and then verifying with the computations whether it is a safe state or not safe state, all the features you are going to be identifying in your lab program gate. So it is completely operating system how Banker's algorithm is implemented, and based on that you will be predicting the sequence is safe or not, whether the sequence is valid or not. Some process will be given and available matrix will be given, resource available is given, and again the need of a matrix will be given. Then again you will be computing within turnaround verifications, and afterwards you will be verifying within all the sequences and how much time it is computing for completing an implementations, and finally you will be checking some sequence whether the deadlock arise or not, if it is a safe state or not safe state. So steady state and not steady state is also considered as your all logic of your Banker's algorithm, right? And next, ninth program, you need to design a page replacement algorithm. So user can design, implement in terms of C, C++ and Java program. And page replacement algorithm, as I told, page replacement is one of the basic operation of any operating system, because when you are having 4 GB memory and 500 GB hard disk, 100% 500 GB cannot be run it within a 4 GB RAM. So some replacement has to be made. So to make the system to be work in a better and efficient condition, we are having some page replacement algorithm. So memory is nothing but a page, the frames is nothing but a frame. So that huge volume of memory that is available for computing the data is now to be executed in terms of a page replacement, right? Some context switch is going to be carrying it, switching one process into another process, allocating memory for one process and to execute that. And again in the page replacement, as an example, we are having least recently used LRU and first in first out FIFO. Some sequence of data will be taken and frame size will be taken. Then we are going to be scanning the data. So the characters will be given as input, text will be given as input. We will be sequentially verifying it. Whether the data is least recently used, we are going to be verifying. So in page replacement algorithm, hit ratio and miss ratios will be there. If the data is available, then it is called it as hit ratio. If data is not available, then it is called as a miss ratio. So hit ratio and a miss ratio are a basic concept of your page replacement algorithm. So this covers the points that is highlighted you can process in an operating system and system software lab program. So this is how that introduction is going to be started for your regular lab system software and operating system, and how that preliminaries can be taken care, and what software has to be installed, and what is an course objective, and what is an outcome the student is going to be gain after completing this lab. And these are the different lab set of programs, what exactly legs, what exactly in theory you will be studying. And again, now program number 3 and 4 you will be having passing technique, and program number 5 you will be having a file oriented intermediate address format, and 6 and 7 will be basically 6th question consists of 2 sub questions. 6th A 6B will be consists of lexical and act, and 7 8 9 again it is an operating system concept, right? So this is the basic overview of your system software and operating system lab, and in the next video we'll be checking each lab programs, its syntax, and again logic, and what is the final outcome of your program. So each program will be continuing in the next upcoming class. So thank you for watching the introduction of your system software and operating system lab.